Addition and subtraction of radicals. Good day everyone. Today I will discuss how to add and subtract radicals, but before we proceed to that, let us study first its parts. I have here the nth root of x. The small letter n is what we call the index, which indicates the degree of the root of the radical term, the radical sign. And lastly, the x, or they call it radicand, the number inside the radical sign. The parts of the radical term will be important later, so keep them in mind. Simplifying by combining like radical. Let us have example number 1. The radical expression is 8 square roots of 3 plus 2 square roots of 3 plus 4 square roots of 3. In adding radical expressions, make sure that they have the same degree of radical and radicand. In our example, all given radical terms have already the same degree and the same radicand. The degree of radical terms is the square root. The radicand is 3. The two conditions that I mentioned earlier are already satisfied. Therefore we can now proceed to add. For you to see the process, I gather all the numbers outside the radical term and place them on one side. So, we have 8, plus 2, plus 4. Since they were all similar in degree of radical and radicand, which is a square root of 3. Then, just write one of them. The square root of 3. Then getting the sum of 8, plus 2, plus 4. Then, is equal to 14. Then copy the square root of 3. Therefore, the answer is 14 square root of 3. Let's have example number 2. The given radical expression is 9 square root of 2, minus 5 square root of 2, minus 2 square root of 2. The same rules are being applied in adding a radical expression to the subtraction of a radical expression. It should have the same degree of radical and the same with radicand. In our example, the degree of radical are square root and the radicand is 2. The conditions are all satisfied. We can now proceed with subtraction. In subtracting, just gather all the numbers outside the radical terms. So we have 9, minus 5, minus 2. Then, since they have the same degree of radical and radicand, just write one of them, so we have square roots of 2. Then, you can proceed to subtract. 9, minus 5, minus 2, is equal to 2. Then, copy the square root of 2. The answer is 2 square root of 2. That is how to subtract the radical expression. Let us have another form of example. Simplify each expression and combine like radicals. Example. The radical expression is the square root of 72, plus the square root of 32, plus the square root of 8, minus the square root of 18. In dealing with this kind of radical terms, you need to simplify them to their lower value. In simplifying each term, you need to factor them. Let us start with the square root of 72. Think of two numbers wherein the product is 72, but make sure that one of the numbers is a perfect square. The two numbers are the square root of 36 times 2, wherein 36 is the perfect square. Let us move to the plus square root of 32. The same process happened. Think of two numbers wherein the product is 32, but make sure that one of them is a perfect square. The numbers are the square root of 16 times 2. Let us move to the plus square root of 8. Let us find its factors. The same process happens. Think of two numbers where the product is the square root of 8, but make sure one of them is a perfect square. The factors are the square root of 4 times 2, wherein 4 is a perfect square, and lastly minus the square of 18. The same process happened. Find its factors wherein one of the factors is a perfect square. The factors are the square root of 9 times 2. We are already done in finding its factors. Now let us simplify. The square root of 36 is equal to 6. The square root of 2 is not a perfect square. Therefore, it remains inside of the radical sign. Plus, the square root of 16 is equal to 4. The square root of 2 is not a perfect square. Therefore, it remains inside of the radical sign. Plus, the square root of 4 is equal to 2. The square root of 2 is not a perfect square. Therefore, it remains inside of the radical sign. Minus, square root of 9 is equal to 3. The square root of 2 is not a perfect square. Therefore, it remains inside of the radical sign. As you see, all radical terms have already the same degree of radical and radicand. Therefore, there's no problem in performing addition and subtraction. As the first step, I will gather all the numbers outside of each radical term and place them on one side. So, we have 6, plus 4, plus 2, minus 3, and. Since they have the same degree of radical and radicand, which are square roots of 2. Then, I just wrote one of them. Perform addition and subtraction. 6 plus 4, plus 2, minus 3 is equal to 9. Then, copy the square root of 2. Therefore, the answer is 9 square root of 2.
For more videos on mathematics, please don't forget to subscribe.